Hello and welcome to another video on vectors, and in this video we're going to be looking at column vectors. So in the last video I introduced you to what vectors were, and I showed you that we could represent a vector on a grid using an arrow. So we've got a vector here and it has a magnitude, which is just the length of the vector, and also a direction. So our vector is going in this direction. But instead of drawing a vector out, we can also represent vectors using some numbers. So this vector I've labelled as A, so let's just write this down over here. And we can also underline our vector, so instead of putting it in bold, we can put a line underneath it to show that it's a vector. Now I can write this as a column vector using the horizontal and vertical components. So what I mean by that is, if we have a look at our vector, if we look at the horizontal distance that it's travelled from here to here, we've gone 1, 2, 3 spaces to the right. So our horizontal component will be 3. And if we think about our vertical component, how far have we travelled in the vertical direction to go from here to here? Well, we've gone up 1, 2 spaces. So our vertical component will be 2. And we enclose that in a pair of square brackets. So this is called a column vector. And it just gives us information as to the horizontal and the vertical direction of our vector. Now you always put the horizontal component on the top and the vertical component on the bottom. So let's draw another vector. So let me get my line tool out. So I'll just do a completely different vector. Let's say we're going from here up to here. And let's change the colour. Let's make this one red. And we need to remember to put our arrow in. We're going in this direction, and if we label this vector, let's label it B this time, or let's change that to bold B, like that. So if we were to write this red arrow as a column vector, we would say that column vector B is equal to our horizontal component. We're going 1, 2, 3, 4, 5 places to the left, and because we're going to the left, remember left is always negative, so it will be -5. And then our vertical component, we are going up 1. So it will be -5, 1. So that is how we write column vectors. We always put the horizontal component at the top and the vertical component at the bottom, and we enclose them in a pair of square brackets. You may also see curly brackets as well, okay, but I'm going to be using square brackets. Now an easy way to remember the order is we always think about going along the corridor and up the stairs. You've probably heard that saying before. When you're plotting coordinates, it's exactly the same with vectors. So always think along the corridor, up or down the stairs. Right, so what I've done now is I've drawn loads of arrows on the grid, and what I'd like you to do is pause the video and see if you can write out all of these arrows as column vectors. And I would probably start with C because I've done A and B. Okay, let's go through this together now. So let's start with C. So we're writing out C as a column vector. Remember, along the corridor up the stairs. So we're not going along left or right. So our horizontal component will just be 0. Our vertical component, we're going down 2 spaces. So that will be -2. So this would be our answer. Okay, let's move on to D, which is in fuchsia. So one of my favourite colours. So D as a column vector. So always look at the arrow. So we're going in this direction. So we're starting here. We're going along 1, 2, 3, 4 places. So that's +4. And then we're going down 1, 2. So that would be -2. Okay, let's move on to E, which is in orange. So let's do it down here. So horizontal component first, we're going 1, 2, 3 to the left. Remember, when we're going to the left, it's negative, so it's -3. And we're not going up or down, so the vertical component will be 0. Okay, let's do F now. So F is in green. Let's go up here. So column vector F, we're starting down here. So we're going 1 to the right, which would be +1. And then we're going 1, 2, 3, 4 places up. So that would be 1, 4. And finally, I had to include G just because that's my initial. And it's a nice maroon colour. So column vector G. So we're starting down here because if we look at the arrow, we're going in this direction. we're going 1, or I can just look at the grid. We're going from 7 to 0, so that's -7. And then we're going from 0 up to 6, so that is +6. So that is our answer. Okay, I've got one more question before I finish, and that is, what do you think the column vector would be if I wrote down -a? Okay, because we know what the column vector of A is, but what do you think the column vector of -a would be? Now, if you watch my previous video, you would know that if we take the negative of a vector, we are just going in the opposite direction. So if vector A goes from here to here, -a would just go from here to here, so it would be the opposite direction. So we would just reverse the numbers. So instead of going 3 from here to here, we're going to be going -3 because we're going in this direction. So our horizontal component would be -3 and our vertical component would be -2. Okay, so that would be our answer. Notice we've just taken the negative of both of our numbers. So if I had -b, well, we don't even need to look at the grid. We just look at our column vector for b, which is -5, 1, and we can just take the negative of both numbers. So the negative of -5, well, that will just be +5, and then take the negative of 1, which is -1, and that would be our answer. And we can check that by looking at the arrow. So -b, we're going to be going in this direction. We're going to do the opposite of what we did before. So we're going 1, 2, 3, 4, 5 to the right, which is +5, and then 1 down, which is -1. So hopefully that was helpful. And in the next video, we're going to be looking at adding and subtracting vectors. So hopefully that's whet your appetite, and hopefully I will see you then. Take care.